Okay, hi and welcome to some video notes on 3.5, which is compound inequalities, and we're going to focus on one version in this section of notes, which is the and compound inequalities. And we'll explain what that is, and then additionally, I kind of want to tag along in an extra point, which is interval notation, or a way to identify a set of solutions, because as we're coming to understand, inequalities are more than one solution. It's really a boundary, and it has a bunch of solutions on either side. Well, today, and let's go ahead and get started. Let's find out what a compound inequality is, which is two inequalities. And they're joined by the word and, which we're going to focus on in this video, and or will come in the second video. We call them, if they're joined by a word and or, with two inequalities, we call them a compound inequality. Now, if we look at this here, this would be an example of a compound inequality. So what we're used to seeing is something that looks like that. -5 is less than or equal to 5. That's an inequality. It means that there's a boundary at -5 and all the solutions are greater than that, all the possible answers for it. But this time what we're going to go ahead and do is add on another inequality. So we're seeing the other inequality, which is x, or the solutions, are less than or equal to 7. Means that there's a boundary at 7 and all the answers are below that. So if you look at this and kind of think about it, these solutions according to the upper boundary, I'm going to call this a high boundary or upper boundary, right? Either way. Meaning the same thing, is saying that we have all of our solutions below that. And if you look at the low boundary, it's saying, well, heck, all of those solutions, our solutions are above that. What we find is that this makes an interval or a bar. And we're used to seeing intervals with bracket notation, meaning that we identify a low boundary and a high boundary, and whatever it is that we're talking about between there is a solution, in a sense. So this inequality can be replace our bracket notation, and we'll talk a little bit about that after we do our first example. Let's get back to compound inequalities, though. If we look at this inequality, -5 is, or this one here with the -5 on the left is a low bound, we would read this as one of these two possible ways. So I would say x is greater than or equal to -5 and less than or equal to 7. That's one way to say it. You could also say x is between -5 and 7 inclusively. See how it's identifying a low boundary and an upper boundary, and it's saying that these are included, meaning there's an equal sign. Okay, so this is a compound inequality. The and compound inequality that we're focusing on today, the solutions make both true. So what you're seeing here visually is what we're going to see for all of these. This is what a and compound inequality will look like, meaning that for both inequalities, the solutions are the same. Okay, and we're going to see that the or is going to be the opposite of that, or it makes one or the other true. All right, let's do a quick example and get right into this. So our first example then says write a compound inequality that represents each situation, then graph. Well, this first one says for all real numbers that are at least -2 and at most 4. So hopefully you can kind of see that -2 and 4 are our boundaries in this scenario. So we can kind of see both of our inequalities. The other cool thing about a compound inequality that I don't know if I called out, and we'll do a little bit more with our example video, is that they can be written together. So, and additionally, you can also always start with them because we're going to be dealing with whatever it is. So we could use x, but let's go ahead and switch this. Let's say that n then represents our solutions. Because n, the solutions, makes both inequalities true, we're going to put it in the middle, just kind of we saw in the notes there. And then we also realize that if we write this, if we put a less than sign on that, it says all the solutions are greater than the low boundary. For an and compound inequality, that'll always be true. It'll always be greater than the low boundary, looking at this one here. And then on the right side, we're also going to put a less than sign, right? And it said that our solutions are less than our upper boundary, and that's what that says, right? If we look at our upper boundary here, the solutions are always going to be less. This is always true for an and compound inequality. So what I'm telling you is that this is always a starting point. Put in your solutions, or the variable that represents your solutions, put them inside of less than signs, always, never greater than signs, never, and then you can address if it's included or not included. Okay, so we've got a good start. Really, all we have to do is place our boundaries down in the right spots, right? You have to put the low boundary on the left always, because of this, and you have to put the high boundary on the right always. So let's put -2, so it says all real numbers that are at least -2, so -2 right? Our solutions are greater than -2, meaning graph to the right, so that means all our solutions are greater than -2, and it says at least, so we have to interpret that. At least means it's included, okay? And at most 4. So that means 4, then our upper boundary goes up here, and that is also included, because at most means that 4 is part of the solution, and it says at least, which means -2 is part of the solution. That's how I know that those are included. So there's our compound inequality. -2 is less than or equal to n, which is less than or equal to 4. Okay, now we're asked to graph that as well. So I've already got a number line populated down below. You can separate these and see them as each part. So we could look at just the left side, -2 is less than n, and graph that part. So let's pay attention to that. Our low boundary is -2. It is included, so I'm going to go ahead and make a boundary point there and include it. I'm going to go to my high side as well, and I'm going to find that boundary, and it's also included, so I'm going to color it in. If it's an and, I know it's the between, but let's graph it each side. Our solutions are greater than -2 or equal to. So I'm going to graph this way for this one, right? And I'm going to put a little arrow there. Why? Because it would be all the solutions up in 2. And then I've also got that the solutions are less than or equal to 4, which means that the solutions at our boundary 4 should go down. They're decreased. And what you'll see is that they overlap. They should always run into each other if it's an and statement. Okay, and you can see the word and right there. It tells you and. A lot of times it will. So there's a compound inequality graphed for this particular situation. Now let's add in one little bit before we're done with this note section, is that interval notation for that same example can be represented as a bracket notation. And we saw that -2 was our lower boundary, and we saw that 4 was our upper boundary. So if we were to put them in brackets, and I think that have that not included, this actually should be a square bracket here, right? But if it wasn't, it would be a rounded. Well, let's pretend actually. Let's pretend it wasn't our example, and this one's close to our example. Let's say it was a rounded bracket that we came with. What this would translate to is that this is an interval with a low boundary and upper boundary, and our brackets decide if it's included or not included. Well, how does that look in this inequality notation? Well, 2 is our low boundary, you can see it here. 4 is our upper boundary, you can see it here. This bracket then would tell us that it's less than or equal to, because these would always be less than brackets, right? Around our unknown or variable. We'd always start like that with that yellow highlighted section. And then this bracket, because it's squared, would say include it. This bracket, because it's rounded, would say not to include it. If that looked like a point, we'd get a colored in point. If this looked like a point, we would get an open circle point because it wouldn't be included. So you can quickly translate our bracket notation into what we call interval notation. Interval notation is very useful and comes up frequently, so I do want you to know that. All right, so just remember, this always works, and you'll always use a less than sign for your interval notation, or greater, less than, or equal to as well. Never a greater than or greater than. Okay, so in this video, we've covered what a compound inequality is. We've covered how to graph it, how it relates to an interval notation, and how to write one. All right, see us for the example videos.